It appears that our models for the development of the early universe have, at long last, had their day. The James Webb Telescope has now identified an entire series of strange structures from the beginning of the universe that shouldn't really exist at all in this form, well, at least on paper. But since the universe is clearly not very keen on our models and hypotheses, it has already detected 6 puzzling galaxies that appear far too large and massive for their time of origin, just a couple of 100 million years after the Big Bang. Now, the most powerful space telescope ever has captured yet another mystery in the heart of a galaxy that existed when the universe was only 770 million years old. Webb detected a gigantic black hole of more than 1 billion solar masses. Experts have no clue how this gravity beast was able to grow to such dimensions when the universe itself was still in its infancy. Could it be that we are dealing here with the remnants of a past universe? After all, we mustn't forget one thing: the Big Bang theory is already facing increasing criticism, and more than a few scientists consider it more logical that the universe is, in fact, going through an eternal cycle of decay and rebirth. Astronomers generally assume that the stars and galaxies of the universe have changed drastically over the last 13.8 billion years, becoming larger and more massive over time by absorbing gas from their surroundings or merging with other galaxies. No wonder, then, that our current cosmological models suggest that, in the early universe, there simply wasn't enough ordinary matter to form cosmic structures the size of our Milky Way today. As a result, experts expected, at best, tiny baby galaxies during this early cosmic period. They were all the more surprised when the images from the James Webb Telescope showed that this assumption doesn't match reality at all. Specifically, Webb found 6 galaxies whose light took more than 13 billion years to reach us. By implication, these structures already existed when the universe was only 500 to 700 million years old. However, despite this, they already had up to 100 billion solar masses. This poses a problem, to say the least, because these puzzling structures, with their tremendous sizes, are in stark contradiction to current cosmology. Unfortunately, the ambiguous explanations also lead to the next research dilemma. On one hand, it could be that the density of matter in the young universe was 2 to 5 times greater than our models allow. Alternatively, these galaxies could have grown in a way that is completely unknown to us so far. Either way, our understanding of early cosmic evolution would have to be fundamentally rethought. It also seems that this applies to our understanding of black holes. For some time, astronomers assumed that the mysterious, massive beasts at the centers of galaxies grew along with their cosmic environment itself, that is, by accumulating more and more mass due to their enormous gravity. Matter that falls onto a black hole forms a rotating, hot, bright accretion disk that continually feeds the structure. In the case of very massive black holes, which have millions or even billions of times more mass than the Sun, an active galactic nucleus, or quasar, is formed. In principle, quasars are among the brightest cosmic objects of all, primarily due to the radiation emitted, which often outshines all the stars in their host galaxies. This dazzling glow occurs because the gravitational energy of the accumulated matter is converted into radiation. As this radiation simultaneously exerts counterpressure on the infalling matter, the system essentially self-regulates and slows down further material accumulation. In other words, black holes can't grow randomly fast. So, how is it possible that so many early examples of these objects are mysteriously enormous? That's precisely the crucial question. In recent years, researchers have found several young quasars in the early universe with black holes up to 10 billion solar masses at their centers. Could it be that these cosmic premature infants were fed by a different mechanism, allowing them to accumulate gas far more efficiently than their modern counterparts? Alternatively, scientists propose that the mass of these quasars might have been overestimated due to the effects of dust. While previous observations didn't solve the mystery, the revolutionary James Webb Telescope now enables us to examine the hidden secrets of quasars more closely than ever. In fact, its mid-infrared instrument, or MIRI, is 50 times more accurate than the tools used in past research. Scientists from the Max Planck Institute for Astronomy used observation time in January 2023 to study what was then the most distant known quasar, named J120+0641. This active galactic nucleus existed during the cosmic dawn, just a short time after the Big Bang. In their study, Webb not only captured an image of this structure but also obtained a spectrum, the rainbow-like splitting of light into different frequencies. However, researchers were surprised to find that this young quasar, despite having a mass of over 1 billion solar masses, appeared astonishingly normal. This applied both to the dust torus, the vast, loose ring of dust that usually surrounds the accretion disk, and the accretion disk itself. Since neither the dust ring nor the inner disk differed significantly from those of modern quasars, the researchers had to content themselves with the conclusion that their mystery had only grown deeper. Not only were the very massive black holes already in place, but so were their feeding mechanisms when the universe was only 5% of its current age. Goodbye, Big Bang. Considering that real observations in space differ so drastically from our theoretical models, an interesting and fundamental question arises: if we were wrong about the early development of the universe, could we be entirely mistaken about its true birth? The Big Bang theory fundamentally describes the simultaneous creation of matter and spacetime from a singularity about 13.8 billion years ago. But how can we know that today? Experts can look back to the beginning thanks to the expansion of the universe, which started with the Big Bang and continues today. By examining this development in reverse, they can calculate back to the starting point. However, we should note that these theories don't deal with the actual Big Bang itself but with the time shortly afterward. Consequently, the theory is still accompanied by many unsolved mysteries and some serious issues. According to the current Big Bang model, the universe should have had infinite density at time zero. However, this idea contradicts the uncertainty principle of quantum mechanics. Additionally, the theory of relativity also has issues with singularities because, in truth, Einstein's famous work loses its validity on this small scale. But now, there's a model called the Big Bounce that avoids these fundamental obstacles by quantizing spacetime, thus avoiding dangerous singularities. What does this mean? Essentially, we're dealing with a cyclical model of the universe, posing a new starting question: what if the end of the universe is simply the beginning of a new one, with scales expanding by several orders of magnitude? Regardless of whether it's the Big Rip, the Big Chill, or the Big Crunch, each of these theories leads to the end of the universe, but what comes after? Either nothing, or a new beginning, just as zeros were dropped during the currency reform of the 1920s so that a loaf of bread no longer cost billions of Reichsmarks. It's also possible to shrink the vast universe in reality by redefining the scales of time and distance. Since the reduced frequencies of radiation would correspond to much higher temperatures, one would have a new Big Bang. This process can, in theory, be repeated endlessly, simply by setting one scale level higher each time. Nikampusi, from the University of New Haven, also believes that the universe wasn't born as traditionally assumed, and that something existed before it. However, this theoretical physicist approaches this complex topic from a slightly different angle. He is convinced that our universe began within a black hole, meaning that accumulated matter from a prior structure could have initiated our universe's existence. Would ultimately arrive where it can presently not be packed. In spite of the fact that this early stage seed might be unbelievably little, it actually weighs a few billion solar masses. Since black holes rotate at practically the speed of light, tremendous torsional forces act on the core. As a result, it's not only compacted but also twisted, much like a spring-loaded toy snake waiting to burst out of a can. Eventually, this seed within the black hole could proverbially burst open and set the formation of a new universe in motion. However, we would then be dealing with a cosmic doorway that could only be crossed from one side. If someone were to fall into a black hole in the Milky Way, it's possible that they, or whatever remains of them, would emerge in another universe. Our own universe could, therefore, be the result of a preceding universe, where the beginning of this mother universe was forming inside a black hole. It burst open 13.8 billion years ago and has been expanding ever since. This implies that we might still be hidden behind the event horizon of a black hole. Thank you for watching this video. I hope you enjoyed this journey into the mysteries of the universe. If you found this video interesting, please give it a thumbs up and share it with your friends. Don't forget to subscribe to my channel for more amazing updates.